welcome back to another video. Today we're looking at question 2, add two numbers, and we will be solving this question in Python. So let's get started. The way we'll be approaching this problem is that we'll keep the pointers L1 and L2 to both the linked lists, and we'll keep moving them like pointers one by one to get the new value, and then keep adding that to the pointers, to the new pointer. So let's get started. Let's create a new pointer. Let's call it dummy head, and this will be a new list node. I wonder if this is, list node. Let's just iterate with the value 0, and then let's call current node. So current node will be the node that will keep a track of the new values. So for example, like 7 and 0 and 8, right? And then once we have that set up, need a while loop, and the while loop needs to keep continuing as long as there are values in L1 or L2, or if there's a carryover, which I did not initialize. So let's do that. So carryover, let's go initialize that to 0. And we also need to know that in the examples that are given to us, so some examples are given where L1 has more values than L2. So we need to keep checking for both. So while L1 is not equal to none, and L2 not equal to none, and carry over is not equal to 0, we need to keep doing it. And what do we need to keep doing? We need to extract the value. So let's say L1 value would be equal to L1.value val. If L1 is actually a valid value, as in like it's not null, or we just set it to 0. I think that's how you do it. I'm practicing my problems in Python after a while, so if there are index issues, actually let's just try returning, and we'll just compile to see if it works. Let's just return dummy head for now. I just want to see if this is the right way to write it. If you try running it, if else, right, of course. Let's just change that and run that again. Okay, so the answers are wrong, but at least it compiles. So let's continue with the problem. So the current value, right, would be equal to L1 value plus L2 value plus carryover. Awesome. But the value for the new node, let's call it new node, would be equal to list node with only the right hand side. So for example, if we add 7 plus 8, right, and then the value is 15, the new node has to be created with value 5, and 1 has to be taken as carryover. So this will be current value modulus 10, and the carryover would be reassigned to current value divided by 10. So basically this double backslash means that give me the integer value rather like so the floor. So for example, if we if this is divided by 10, right, so if 15 is divided by 10, 15 divided by 10, this will actually give us 1.5. But if we do 15 backslash 10, this will give us 1. So basically you're getting the floor of the integer. So that's the reason why you need to do that. Once we have that, so current node dot next, you need to attach the value that you have. So it'll be new node, right? And then and then the current node will become the new node. So that's good. and we have shifted the pointers to the new node. The next thing we need to do is actually move the pointers for L1 and L2 as well. So L1 would be L1.next if L1, else none. So basically, if there are still values that are remaining, you assign that. We move forward. If not, we just assign none. So L2 would be equal to L2.next if L2, else none. Awesome. And in the end, we just need to return dummy head.next. And the reason why we return dummy head.next is because since we're moving the pointer here, right, we need to return the head. But how do we get access to that unless and if we move back? We can't even move back because we don't have any way to actually move back. So that's the reason why we created dummy head that just points to it, and we keep adding to that. So since all of the values are only added after dummy head, you can return dummy head.next to actually give the right values. Awesome. So let's try compiling this. Ooh. All right, let's see what's up. Current node dot next is equal to new node. Current node is equal to new node. Did I miss something? Sure, I missed something. Wait, is this? No, that's correct. Dummy node dot next. But it doesn't point to anything. So current node, new node, this node. Okay, let's try debugging this. Print current node dot val. So oh, okay. So I think no. So this is correct. This is correct. Okay, so let's actually print out. So nothing is getting printed here. So let's print the carry value here. Oh, new node. No, even new node is being initialized properly. Okay. Let's try that again. Why isn't it printing anything either? Oh, okay. So basically, classic mistake. Okay, let's try that again. Okay, cool. So the problem, what was wrong with my solution was basically I was checking if all of the conditions were held, and then the carryover was already set to 0, so it was never actually entering the while loop. So that was a problem. So once we fix that, the first few test cases are okay. Let's try compiling this. Everything else is okay as well. Awesome. Okay, so let's talk about this based on the time complexity of the solution. The time complexity of the entire solution is O of n. Since we have to iterate through all of the nodes to get the value, the space complexity is O of n as well, since we are creating space for the solution that needs to be returned. Awesome. If you have any questions, please let me know in the comments below. Don't forget to subscribe to the channel and like the video. I would really appreciate that. It definitely keeps me motivated to make more videos. Thanks so much, and I'll see you folks in the next video. Peace.